From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
We can do a very effective, very efficient job at taking the material that is on the surface and dissolving that material or reflowing it, forcing it to reflow so that we can heal all the imperfections on the surface that come from the layering. It comes from porosity, it comes from any additional support structures that were at some point on the surface, or that, in the case of powder-based technologies, any partially fused powder that is on the surface. And when we reflow it, we're basically creating a part that has been coated with a material of its own, and hasn't changed the mechanical properties of it. It hasn't changed the dimensions of the part, and it also has healed all the imperfections on the surface. And by way of healing the imperfections, because of that, any property that is dependent on or that has issues with initiating, with crack initiation at the surface, that's erased, and that's where the material or the ultimate part sees most of the boosting properties.
That was Luis Folgar. Luis is the Executive VP of Technology at AMT Post Pro. AMT is one of the industry leaders for automating 3D printing post-processing. Luis has a wealth of experience in the additive manufacturing sector, working previously at Nike and Paramount Industries, where he applied his material science expertise to the world of 3D printing. He joins the show today to talk about one of the most underrated parts of the 3D printing industry, post-processing, and how AMT is working to automate this part of the 3D printing workflow. Great. So welcome to the show. Why don't we get started and have you tell the audience a little bit about yourself and the company?
Sure. Thanks a lot for this opportunity. It's great to be with you, and I appreciate the opportunity to just talk to your audience and all the fans and all of us in the additive manufacturing industry. My name is Luis Folgar, and I've known you for a number of years. I've known of you, and I've been hearing a lot of good things. So really excited to engage with you. I'm the CTO for Additive Manufacturing Technologies, a technology company that focuses on post-processing solutions for the 3D printing industry. We're based out of Austin, Texas. Austin is home for me. I've been here for 3 years now, and prior to AMT, I've been fortunate enough to be part of multiple programs with large and small companies, anywhere from product development to OEMs and printer manufacturers, through end users like, prior to AMT, Nike, which has been a phenomenal experience, and I still have very good ties and friendships there. It's been, for me, the career has revolved around additive manufacturing and 3D printing since the very beginning, and I don't regret it. It has been very rewarding, and I don't see myself changing industries anytime soon.
Awesome. So I'm really excited today to talk about post-processing, because I think that's something we really haven't covered in a great deal in some of our previous episodes. So why don't you talk a little bit about AMT and kind of what the focus of the company is? What sorts of products do you guys have that supports the additive manufacturing ecosystem?
Yeah, absolutely. Additive Manufacturing Technologies started in 2017, and Joseph Crabtree really had the vision to do something different for the 3D printing industry. There is a lot of promise on the technology, whether you're doing metals or plastics. I think the future, like they say, it's here today, but the reality is that to produce these phenomenal parts that our technologies are producing, there is still a very significant amount of effort and labor involved. A lot of it comes from the post-processing that has to be done in order to the part to be finished and before it's ready to be used. So, post-processing has been around since the very beginning of rapid prototyping back in the day. As it has evolved into additive manufacturing, I think the biggest change has been on the printers, all the improvement that has been done on the materials, the material portfolio, the performance of those materials, the robustness and repeatability of the technologies. It's been phenomenal. I mean, it's just been an all-around great story for the manufacturing industry. But ironically, what hasn't changed is being the post-processing side of the equation for 3D printing and for additive manufacturing. So that's where, Joseph saw the opportunity to focus on that particular challenge, because it really is the barrier to transition to production. And our company brings a very unique approach to automating the workflow that needs to take place before the part is ready to be used. So from the moment that it is done out of the printer to the cleaning, the support removal, or the surface treatment that needs to be done prior to that part being usable. And essentially our flagship product, for us, we started with surface smoothing, because everything that we face today, a lot of the issues when it comes to parts being fragile or properties not being where they need to be, they start at the surface. Like my background is material science engineering, right? So I really focus on material properties, the design of the material, what is the right material for the right application, what is the most efficient process with the right material for a given product. So when you truly get into the science of materials, you can design a material for an application and for a process. But, when it comes to additive, all of that is caveated. It needs to be caveated with the fact that we have a layer by layer process that significantly it throws a wrench, right, on the whole equation. It needs to address certain things that come from both material and process interactions. And no one has been able to control those so far. Even, when the process or the printer manufacturers try to do it through software, for example, or when the material companies try to do it through material properties and design of materials, it just cannot be accomplished, because you cannot predict a lot of different processing conditions for different geometries. So it really opens up this opportunity to look at it on a different way and say, you know what, let's look at it from an additional step, an additional post-process that needs to be done. And if you get scientific enough, you understand that the root cause of all the evils starts at the surface of the parts because of the layers. So that's where we focus on, and the flagship product has been a vapor chemical smoothing process. And from there, we expanded into a depowdering and support removal, coloring, and a whole gamut of offerings that we're now looking to integrate and provide as a solution for automating the entire workflow.
Do you focus on a specific type of technology? So SLS, MJF, DMLS, where is kind of the sweet spot for the processes that you've been developing?
Yes, our technology has focused around plastics and essentially thermoplastics. And we find that at the moment, it's the adoption of the thermoplastics has just exponentially gone up. And a lot of the solutions that we offer are targeted to thermoplastic, whether it is powder-based processes, for powder-based fusion, or extrusion-based filament extrusion type of processes. Great success. We try to remain agnostic to the process and the materials. So our solutions are universal, if you will. as far as solutions for the thermoplastics world for additive manufacturing.
So I imagine there, being a material scientist, it's quite a exciting field because you get to kind of look at the MSDS sheet in reverse and say, what's going to eat away at this part and give me some smoother surfaces. So when you're thinking about how to kind of address the challenge of surface finish, let's take SLS, for instance, or MJF, whatever it may be. Most of the materials right now are PA12s, maybe PA11s, but that's quickly expanding into some elastomers, into polypropylene and others. Does your process kind of scale with that? Do you have to change formulations and do different approaches depending on the material, or is that something that you're trying to build out as the industry grows there with new materials and profiles of available offerings?
Yeah, absolutely. Yeah, I agree with you. Being a material scientist, it's almost you're wired to selectively look at different properties and find different solutions that work with for different materials, right? And if you look at a solution for smoothing, or in this case, dissolving a plastic, which is essentially what we're doing, just in a very controlled way, the challenge is, how do you find one chemical that can do the job for all the different materials, all the different thermoplastics out there? And that is where the key in chemistry knowledge and the research and development that went into this technology came into play, where we have one chemistry that will treat essentially about 95% of all the thermoplastics that are out there. And it works, it's phenomenal. There has been a lot of science that went into, and I can get into it. Don't want to bore all the audience with all the scientific stuff behind it. But essentially, we found something that it's been tuned with the polarity of the polymers, so that we can dissolve them, we can treat them without damaging the polymer chains. And essentially, by introducing engineering controls with the equipment, we can do a very effective, very efficient job at taking the material that is on the surface and dissolving that material, or reflowing it, forcing it to reflow, so that we can heal all the imperfections on the surface that come from the layering. It comes from porosity. It comes from any additional support structures that were at some point on the surface, or that, in the case of powder-based technologies, any partially fused powder that is on the surface. And when we reflow it, we're basically creating a part that has been coated with a material of its own, and hasn't changed the mechanical properties of it. It hasn't changed the dimensions of the part, and it also has healed all the imperfections on the surface. And by way of healing the imperfections, because of that, any property that is dependent on, or that has issues with with crack initiation at the surface, that's erased. And that's where, the material, or the ultimate part, sees most of the boosting properties. We're talking about elongation of break, for example, impact resistance, fatigue under load, and those type of properties.
So as you kind of work to get this solution into the more hands of users, where in the process do you usually start that conversation about helping someone improve their overall workflow and post-processing? Is it kind of right when they buy the machine, they realize, okay, we're buying an SLS or MJF system. We know what the raw feel of these parts is. That's not going to be good enough for us. We need to find some solution to do that. Or is it kind of immediate right when they're buying the printers, or do people have to kind of fumble around? It's like, we got this part, we wish it was smoother. We can have some guy sand it for a while and dip coat it or something. Like where in the kind of the ecosystem on the sales side do you guys usually start the conversation with showcasing your technology?
A great question. I've been pleasantly surprised to see that now it's starting a lot sooner. Um, it's not uncommon these days to start a conversation before the sales of the printer happens. So, and I think that's a result of the hyper awareness on the lessons learned from the past, right? People that have tried to enter 3D printing thinking that, all of a sudden there's going to be this magic switch that changes from traditional manufacturing to additive manufacturing, and learning that it's not that easy because there are challenges like post-processing. I think all those lessons have been learned and are taken by the newcomers to pay attention to the entire workflow from CAD to part, right? And that includes post-processing. So we are finding ourselves being plugged in very early on in the conversations, which is very pleasant. But we also, are working with a very large existing customer and user base of 3D printing technologies, which they are what they have, quote unquote, has worked so far, works for them, and they don't necessarily see the value of why switching at the moment. They've made it work. Remember, I mean, these people have spent years, sweat and tears to make a very imperfect process work by whatever it takes, and it has been a tremendous amount of effort. But for those that already have a process in place that has worked, it is a re-education to just teaching how to do things better. And one of the challenges that we've seen is that we have to re-educate the entire industry about post-processing, because there is this very negative connotation about post-processing. When you think post-processing, you think like very dirty work. It's an extra step. Now it's going to take longer to produce something that is already takes it's very slow, and you're adding cost to something that is already very expensive. So, all those negative connotations we're dealing with, and saying, what, this is exactly why we're doing it, because there is a better way. And it has worked out really, really well. And what we're seeing is that there doesn't have to be, we're trying to change that negative connotation of post-processing, so that, think of, for example, like the film industry, right? Like you have the concept of post-production, right? Like you film like an entire movie, and it's the editing portion of it after the movie was shot. Like it's is that post-production step that really deliver the final quality product of an hour and a half film that you and I enjoy, right? And it is only through that you really distill the essential of the product. I think that's what we've done. And that, by the way, that's actually like a really good analogy, because that industry has come up with a very automated way to do that, because it takes so long and it was so tedious of a process. So, I think that is essentially what we're doing. We are completely automating the post-print workflow, so that we can have parts that, yes, they have been 3D printed, but guess what? You can't tell. Like you wouldn't be able to tell that they've been 3D printed, because they look so good. Like there are no layers in there. So it's very exciting.
And I imagine part of the automation process that you guys are building in this ecosystem is that lends itself to a level of repeatability as well. I mean, I've dug out parts out of SLS builds and had to clean them and put them in the blaster. And I mean, if you're tired one day, sometimes you get more powder out than the next day, and sometimes you're lazier in sanding than you are for one part than the other. I mean, in your process, you can lend a certain level of automation, especially as some of these part requirements and production jobs get larger and larger, right? It's only going to go up. And so having that back end process really at each step, depowdering and smoothing and whatever else may build efficiency over time.
Yeah, bingo. And I mean, you just hit it. It's and it's interesting, because that's the story of our company. We started with surface smoothing, but guess what we learned is the single biggest variable of surface smoothing. The result of the surface smoothing process was the quality of the upstream depowdering or the cleaning step. And because it's so variable, it is still human, right? Like there's a person on the other end, sort of like doing the finishing and the turning. If they're having a good day or a bad day, you're going to end up with a different part. Like so, we can't move forward as an industry when that's the reality on the ground. And that's where we decided to go and offer an automated solution that can guarantee a uniformity and repeatability through that workflow. And it's being received very, very well. We keep improving that technology. I think there is much to be done. And the idea is to make it repeatable no matter what the geometry, no matter what the material, no matter what the process. So there lies the challenge of being able to offer something that is universal and that it works every time, no matter what the conditions. But so far we have been doing it very well. And the customers, all those people, I think where we're very successful is in engaging with those customers that, like I said before, they've made it work, right? They understand what they have and why it works. We want to listen to the voice of that customer, because if you pay enough attention, they have the solution. I mean, it's just a matter of having a company that is willing to invest in the time, resources to turn a business around it and turn it into an automated piece of equipment.
And when I think about kind of smoothing, kind of going back to the smoothing conversation, especially with kind of SLS and maybe FDM parts, generally when I think of it, you kind of have two options, right? You have the mechanical, like throw some media or rocks or ceramic, add it in a bucket and vibrate it around and add some water, and you can smooth it that way. That's probably limited by kind of geometry and overall dimensions. Is there other kind of advantages that chemical smoothing would have over some of the other means? I can only think of mechanical smoothing, but what do you guys see as kind of the key advantages for the chemical approach or vapor approach?
So, I think you just hit it. I mean, you understand this very well. You can. You don't have to focus on just tumbling or mechanical tumbling, for example. I mean, look at sanding, just hand sanding, for example. You can get a really polished part, right? But think of like the amount of effort to get there. And not to say that there are some parts that you just, like you said, depending on the geometry, you just cannot do it. So I think that's the biggest attribute, like the biggest advantage of vapor smoothing is our ability to control the areas that get smooth and do it in a very uniform way. So think of, external versus internal cavities, or think of lattice structures, for example. How do you ensure and guarantee that the same level of surface roughness that you have on the outside, you're going to have on the inside? Well, you can do it through different ways, maybe through slurries and tumbling, but it's when you compare those two approaches, in one, you're using media and you're eroding the surface of the part. You're putting now microplastic into detergents that have to be treated before they get disposed. There's water involved. So there is a lot of like soft cost that, again, it's all labor, right? Like we can automate it, but there's still labor in the downstream treatment of those disposables that needs to take place. Plus, there is also a fair amount of knowledge that, depending on the material, depending on the geometry, you now have to select and keep in stock different sizes of media, different shapes of media, and build that, all that recipe for any different occasions. So that's what the vapor smoothing, when you have a chemical that can work for any geometry, any thermoplastic, allows you to just automate the entire process, do a closed loop treatment so that it's safe, and do it in a way that you can use only what you need, focus on just like using the amount of chemical that you need to treat that batch, and recycle it, reuse it. Like, why use water if water doesn't need to be there? Why waste chemical when the chemical can be reclaimed and reused? Why put plastic in the water downstream, microplastic from the all the stuff that is being eroded from the surface, when we can use it and actually reflow it to coat the same surface? So it's a much cleaner way. But again, I'm trying. Hopefully, it doesn't sound very simple. I think it's been a fair amount of engineering that went into creating the controls that allow us to do that. So kudos to our engineering manufacturing team, because yes, vapor smoothing, for those of you that are experienced, it has been around and it's been done for many years, but it has issues with the type of chemicals that were used at the time, and with the methods and the technologies, the way in which it was delivered also. So yeah, very proud of what we've accomplished, and I certainly appreciate you fully understanding what the challenge is.
And when you mentioned in the beginning that you guys are also looking at some of the like, once you smooth it, or maybe before you smooth it, you have some coloring options as well. Can you talk a little bit about kind of just what have you seen in the industry in regards to color? I mean, especially for the FDM and SLS world, you have, like Henry Ford said, I can give you any color you want as long as it's black or white.
Yeah.
Right? Or gray after it goes through some cleaning process in the sandblaster.
Yeah, color is a very interesting one, and color has always been this almost like the next frontier for no matter what process you have. It's we live and breathe. We are just emotionally attached to color, right? So anytime that you put color on a 3D printed part, even if it's a bad print, it just looks better. But applying color on 3D printing, it's challenging, because you can put it on the material, you can compound it into the plastic, but after it goes through the extrusion process or the printing, the fusion process, it changes, right? You can't fully nail it. Whoever needs color, aside from black, like if black is easy, or white. Whoever needs color typically has very strict requirements to really nail it and do a color matching or meet a specific spec, or they're staying within a very specific Pantone color, for example. So trying to do that is very challenging, and what we've found out is that you can do it before or after. With our technologies, our approach, surface smoothing, it doesn't matter whether you do it before or after, or if you did it in situ, like for example the multi-jet fusion process, where you can print in color right now and gives you all the color capabilities. A lot of extrusion-based processes now have the capability of doing multicolor materials and very vibrant colors too. Those are always going to be filtered or slightly modified because of the imperfections on the surface. So if we can put this uniform finish on the surface, I think you get a more vibrant, true color, and you get better retention of the color, and it just looks like a molded part. With the technology that we've, by being able to control the process, now all of a sudden we can control the amount of glossiness that is on the surface, for example, because you can treat a part. If you're trying to smooth it, like, how smooth is smooth, right? So it's a very subjective term. And because of that, we were fully aware that we had to be able to quantify it. And if you get to that point where you can control it, then you can envision parts that can have some texture or that can be highly polished and smooth, right? But if you have those capabilities, when you introduce color, now you can play with different levels of glossiness, different levels of resolution on those colors. So, but we are also able to introduce colors on the parts afterwards for, if you're using powder-based processes and you're using white powders, for example, to do it after. And, when you have a rough surface, if you're putting the color after, think of when you're painting a wall, right? Like the amount of paint that you use to cover a rough surface is very different. I don't know if you paint in your house, but I remember painting my my home, and anytime you have a rough surface, you spend a lot more money, a lot more paint, and a lot more time going over those walls. So it's the same concept here. When you have a rough surface, you're going to need a lot more dye or a lot more temperature, pressure, and exposure time, so that you can achieve the same result as if you had a smooth surface, for example.
Right. Do you see particular industries more excited about your technology and the potential to get really smooth injection molded looking parts with your process that are really pulling kind of their vendors or kind of their suppliers to use your technology?
Absolutely. I think that, hands down, the biggest interest we've seen has come from the consumer product. Consumer product is just because, just the appeal, the appearance of the part means everything, right? Like if it looks like a prototype, it's just will never be considered for as an end use part. Even if it has all the properties, even if on paper it's got all the credentials to perform, you just can't convince, you can't get past the visual. And I think because of that, we've seen consumer products being hypersensitive and very, very interested in engaging at a very aggressive level, to the point that they want to further develop this process. They want to invest in these areas to really solve these issues for the 3D printing industry. And then aside from that, we've seen others where once they realize the boost that they see on the mechanical properties or the performance, they start demanding that finish, because it's that surface perfection, if you will, that is what is giving them the extra performance in the better properties. So, and in that respect, I'll say of those industries, I'll say automotive is one of them. Fatigue resistance, fatigue under load is very important, and also, needless to say, is we're sealing the surface of parts. So a lot of times, if the part is exposed to fluids, or whether it is water or any other chemical, you get rid of that process without the need to coat or infiltrate and seal the parts. You're just doing it through the vapor chemical smoothing.
Awesome. And we were talking a little bit before we hit record about your new facility in Austin. Can you tell us a little bit more about that?
Yes. So our headquarters here are in Austin, Texas. We're actually in Cedar Park, just north of Austin. We opened the facility last year, just before the pandemic. Worst time to be opening a facility, right? We couldn't, even up until now, we haven't had the opportunity to have a proper open house. But it's been very, very interesting and comforting to see that a lot more people are coming by and visiting us. We have an entire demo room for our our customers. And essentially what we do is the center of excellence for the technology here in North America. We do all the training, sales and marketing out of this facility. We have the ability to do R&D and engage with multiple customers that want to explore this technology further and use it for things that wouldn't be out of the box. It wouldn't be so obvious to you and I. I mean, we get surprised. It's like everything, right? Like you create this tool. I think we've created this tool. We put it in the hands of customers, and now your customer figures out how to use it in ways that you had never expected. I think that's what's happened. So we have the ability to engage with customers and further develop things. But everything is done here from Austin, and Austin is just a phenomenal hub for 3D printing, as you're aware. We have University of Texas, UT at Austin. They're phenomenal, and we have other industry partners, OEMs, material providers, service providers, service givers. When it comes to 3D system, when it comes to 3D printing, I'd say Austin is really a hub for North America, and we're very proud and happy to be here.
Fantastic.
So have to visit sometime.
Absolutely. Definitely get out of the Chicago weather. So is there anything you're looking forward to in 2021? You got the facility open, or are there any on your tech roadmap or any events that coming up that you're excited to talk about?
Yes, we're looking forward to all the trade shows coming back. I mean, believe it or not, I think it took 2020 to realize how important the face-to-face and the interactions through all the industry shows are. So we're looking forward to those coming back. But also as a company, I think we were able to respond and react and change our strategy. So we quickly pivot to what 2021 will bring and what the demand is going to be like. And what we're seeing is that in order to predict what the new trends or the new things that we should be doing in 2021 are, I think you need to look at what didn't happen in 2020 and understand that a lot of people, as we all get back to work, are going to be in a rush to get caught up and get those things done. And one of those is integration, being able to integrate all the different modules for the workflow. And for us, that has been, I think, the biggest goal for 2021, being able to offer the full integration, end to end when it comes to the post-processing workflow. And we have a lot of announcements coming up on that front. We were able to, one of the ways that we responded to the pandemic was also to go full on the R&D mode. So we actually invested in the research and development so that we didn't get behind and we didn't get delayed on the development roadmap for our product portfolio. So, I'm really proud of what the team has done and what we accomplished while some of us were working from home or with a reduced staff at our facility. But new models and new capability for both surface smoothing and also de-patterning, and the integration of it all has been something that we're very proud of, and we're very excited to launch it and release it here soon.
That's awesome. Well, Luis, thank you so much for joining today, and hopefully see you in person soon.
Absolutely. Yeah. And I can't thank you enough. I appreciate it. And kudos to you for making, this podcast available. Thanks a lot, Mike.
Thank you.